Welcome to the Calculus A section. In this section, we'll be looking at the limit of a function, the predecessor of a derivative. Now, let's recall some notation to denote a function. We generally use f of x, g of x, or y, etc. But we also know that a function can behave differently at different points of space. But without a graph, we have not yet determined a way to analyze how these functions behave in space. Now we have limits to determine and model how these functions do behave at any given point. So let's say that we have the function x minus 6 over x minus 5, and say we wanted to deal with this at the limit as it approaches 7. So we have our first method deemed plug it in, and plug it in, all that indicates is that we plug in the value that approaches. So 7 minus 6 over 7 minus 5 will give us 1 over 2. And all this is saying is that, say we had this function x minus 6 over x minus 5. As the value approaches 7, we're going to call this 7, the y value is going to be half. So we don't know exactly where, if it's coming like that, if it's coming like that, or if it's here. But we do know that at the value 7, x equals 7, we will have 1/2. Okay. So now we have our second method, and our second method is deemed algebraically isolate x. So let's say we were given the function, let's say x squared, let's say x squared minus 9, okay, over x minus 3. And we wanted to see how this function behaved at x as x approaches 3. So if we just tried to plug this value in, we would get 9 minus 9 over 3 minus 3, and that's 0 over 0, which is undefined. That doesn't really tell us how the function behaves at x equals 3. So what we're going to do is we're going to use difference of squares, which we did learn in Algebra 2, and we're going to say that x minus 3 over x plus times x plus 3 over x minus 3 as the function, as the limit approaches 3. So we can cross these out, and now we can revert to our plug it in method, and we can say that the function x squared minus 9 over x minus 3 as x approaches 3 is equal to 6. Okay, now the last method, or the vertical asymptote method, is a little bit more tricky, and it takes a little bit more thought. So let's say we had a relatively complex function, x squared minus 2x plus 4 over, let's say x squared minus 4x plus 4 all over x minus 3 as the limit approaches 3. Okay, so here we can see that if we plug in 3 again, we'll have a value over 0, and we don't want that. And if we expand this, we actually get x minus 2 squared over x minus 3. And again, if we plug in our 3, we will have a value over 0. And that's no good again. So what we want to do here is we are going to approach the value 3 and get as closest to that value as possible without actually putting 3. So similar to how we did tangent lines, we are going to choose points that are very close, get closer and closer and closer until we are virtually at 3. So let's say we have the value 2.99. Okay, and then over here we're going to say the limit as x approaches 3.01, because these are both equally close to the value 3. So we're going to plug in our respective values, 2.99 minus 2 squared over 2.99 minus 3, and 3.01 minus 2 squared, over 3.01 minus 3. And so on the left-hand side, we are going to get negative 98.01, and on the right hand side we're going to get 102.01. But we're not done there because we want to get a little bit closer to the value 3. So we're going to say the limit as x approaches 2.999. I know that's a little extensive, but we're just being sure, mathematicians. Minus 2 squared over 2.999 minus 3. And that is going to equal negative 998.01. And now, 001. It's important. And the limit as x approaches 3.001 is going to be 3.001 minus 2 squared over 3.001 minus 3, and that's going to equal 1002.001. So we can see that from that 0.001 difference or that 0.009 difference, that there is a large increase or a large decrease approaching either plus or minus infinity. So this means that the value as x approaches 3 for our function x squared minus 4x plus 4 over x minus 3 is going to approach some infinite value as it equals 3. And that is very indicative because if we have a general function, let's say we have something that looks like this, and this is x equals 3. We're trying to find the limit, and it's going to approach, if we're saying from the left-hand side, it's going to approach negative infinity, which is this left-hand side, and from the right-hand side, it's going to approach positive infinity. So this is very, very clear to understand graphically, and it's depicted here in the limits. I hope that helps. If you need more help with problems or insight on the topic, there are a bunch of resources on the website, and I hope that helps. Thank you.